Hi everyone, in this video we would like to cover problem number 66 for Think Through Precalculus. So here we go. Determine the minimum value of y equals, let's just try to write it down, y equals cosine squared 5x, and we have minus 4 times cosine 5x, and we have plus 6 out there. Right, so let's just try to read what I wrote down on the think through. I wrote down that let cosine 5x equals t for real x and t. Why? Because we wanted to somehow reduce the amount of variables. We know that cosine 5x keeps bouncing back and forth from -1 and 1. So in other words, what we're going to do is that the first idea that we really wanted to cover is that cosine 5x, in fact, can be rewritten as t. And we all know that cosine 5x equals t is going to be locked between -1 and 1. So for instance, I can write it down that t is going to be locked between -1 and 1. And we understand that this particular interval never contains anything about any of those vertices, vertex information. So here we go. This is what has happened. We have t squared minus 4 times t plus 6 out there. And if you just think about what has happened, it's going to be t minus 2 squared and plus 2. We're adding it up with 2. Right, so this is the first information that we wanted to cover. And if I just simply graph this, of course, not using the fact that t is going to be locked between -1 and 1, we'll just use this particular fact that the vertex is going to be 2, 2. So we get 2, 2 out there. So that's going to be 2, 2. And all we need to do is just to sketch from -1 to 1. So I would say from -1 to 1, it's going to be somewhere down here. So if I draw the vertical line like this, and if I draw another vertical line, well, this is going to be when t equals -1, and this is going to be when t equals 1. So we just color this portion again, like in a thicker form, and all we need to find out is the minimum possible value. And the minimum possible value goes, reaches out for y value. All we need to do is just to plug t equals 1. Well, t equals -1 is farther away from the vertex, so it's going to have the maximum value for this given problem, but we get t equals 1 out there. So at t equals 1, we get y equals 1 minus 2 squared plus 2, and that becomes 1 squared plus 2. And in fact, this turns out to be 3, and that shall be the answer.